Hello, my name is John Hedengren, and I'm going to give a presentation on generative AI for process systems engineering. First of all, I'll talk about the trends in data and generative AI, also a process systems engineering or PSE overview, and then how generative AI can be applied in process systems engineering with a number of examples. I'll talk about the strengths and limitations of the current technology and how it can be applied, and also some thoughts about how AI increases human intelligence, as Salman Khan mentioned in one of his presentations. I'll then give a research overview and conclude. So let's look at the current trends in data. This is 2010, 15, 18, 2020. This is projected for 2025. 2030, 2035, and these are the number of zettabytes of data that is being generated. Now that comes from the Internet of Things, from these smart devices, also videos, cell phone cameras generate a lot of that as well. It needs to be stored and transmitted, but there's also things like YouTube or Netflix that transmit a lot of data as well. Okay, so there's a lot of data being generated, but we want to focus on industrial applications, in particular process control applications and how those sensors are stored and transmitted and used. And we look at a typical automobile, electric vehicle, for example, 25 gigabytes per hour with some of the computer vision processing on board to enable self-driving cars. You look at wind farm, or also you have these jet engines that generate quite a bit of data as well. So there's a lot of data being generated across many different disciplines. As we look at things like self-driving cars, to enable this type of technology, you have cameras or LiDARs or other types of sensors that are avoiding collisions and detecting objects in the path. Okay, so there's also Andrew Ng. He gave a presentation at Stanford and mentioned that supervised learning right here is going to continue to be kind of the largest value from AI, where you have labels, you train these classifiers or regression models, and then apply those to make decisions. Now, what we're going to be talking about here is generative AI. Okay, this smaller piece of the puzzle, but it's going to be growing much faster percentage-wise than the supervised learning or unsupervised learning or reinforcement learning, maybe a small piece right there from his perspective. But one of the things that we've seen recently is that AI is, in particular, ChatGPT, if you give people an overview of how to use it, better prompt engineering, you see that the distribution, this red right here, you improve over the quality that you would receive without it. And this was 700 and something knowledge workers that are in a related field, but they found that 12% more tasks were completed, 25% faster, and 40% higher quality. And so what can we do to use this as a tool to augment worker performance, especially in process systems engineering? I'll give some examples about how that might be possible. Okay, so let's look at process systems engineering. And the field as a whole includes many different things. We think of like process design and simulation. We might think of advanced and base process control, but it also includes environmental impact and sustainability, understanding and studies, supply chain and operations, decision support and optimization, safety and risk analysis. There's also an element of project management in process systems engineering, as well as process diagnostics and monitoring. And I guess I have that one in there twice. Okay, so project manager, I should take that one out. Okay, so if I look at the typical breakdown of a process systems engineering job, this would be like what I might have done when I worked at ExxonMobil. All right, so we had things like expense reports, and that might have taken up 5% of my time, or safety meetings, developing the safety culture. There's these overhead things that are very important to be able to keep the business running and do it safely, but aren't necessarily the traditional things that you think of as process systems engineering. And included in that is communication, like email. Okay, just responding. And I'd suggest that writing reports is also another form of communication. Be able to clearly communicate to others the result of some study or a project. Okay, and then that might be technical work as well. This is going to be just day to day. Somebody asks you to do some kind of a study, and so you're working on this using math or your knowledge about this area to be able to solve these problems. Okay, and then I had a bit of base level control as well. Somebody had a question about, well, why isn't this extruder turning on? I need to go into the code and be able to understand what's preventing it, or be able to make modifications for the base level controls, and then also advanced process controls. So when I had time, working on these models for polymer control and developing them and testing them. Okay, so that might have been one of my typical breakdowns in terms of my engineering job there. All right, but let's look at the expense reports. Okay, so here's a receipt, just uploaded the receipt. This is not mine, but I asked it to create an itemized list. Okay, and then put it into JSON format. Maybe I could upload it and be able to facilitate extracting the information from those receipts. Okay, and then let's say I had a process and instrumentation diagram. Somebody said, well, let's analyze the safety of this system. Okay, and let's start with something simple first of all. All right, this is just going to be a pressure controller, and it's a cascade pressure controller. Oh, and it keeps advancing on me. Okay, so there's my pressure controller, and I have a flow controller as a secondary controller. And let's go ahead and just look at what it does when I want to analyze this. Okay, so here's the first one. Describe this process and instrumentation diagram and give an overview of the control system. So it recognized the FT, the PT for flow and pressure transmitters, and then also the pressure and controller and flow controller as well. And it gave a reasonable description of this. Okay, let's describe this process and instrumentation diagram, and we'll give an overview of the control system. All right, now this one's a little more complicated one, and it did a very good job for this separator of picking out the instruments, the safety devices, other key elements, and then gave an overview of the control system and potential safety issues as well, to prevent leaks or corrosion or other things with this vessel. So overall, very good job at analyzing this image and able to pick out the control system or mitigation strategies for the safety. Now, what can be done to reduce particulate emissions from these flares? So I just uploaded an image, and it gave some suggestions about different things, 10 different things that could be used to reduce the emissions from these flares. Some of them are, just don't send it to the flare. And those are, making process changes to prevent the waste gases or equipment upsets, but also better flare practices. And those might include different types of ways to get rid of these waste streams. So overall, very good job. Now I'm going to show an example of where this didn't work so well. Okay, so now create a Python program that analyzes an image of a flare and reports the BTU content of the fuel and remedial actions suggested, such as injecting steam to increase mixing or reduce the smoke. Okay, now it just gave a very simple example here. It didn't do any image analysis or convolutional neural networks, and so it even said that this is a basic simulation, doesn't perform any real image analysis. I was looking for something a little bit more, and my prompt may need to change and break this down into more specific pieces in order to get me to that point. So let's look at now distributed control system programming. Create an example program for a Honeywell TDC 3000 to calculate flare BTU content. I'm going to use 2 flows and 3 analyzer values with these example tag names there. Okay, so it's going to create an example program for me. This might be in a TDC 3000 using CL code or, and so this is a legacy system. It's a very old DCS system, a distributed control system, and maybe some of the operators, or not operators, but the engineers, the application engineers, process control engineers may not be as familiar with this language. Maybe it's a legacy system that's hanging around, and so using ChatGPT to help analyze this can be a good idea. Now, the downside of that is if you have any company proprietary information in there, you may need to change tags or anonymize it before submitting that. All right, now let's look at programmable logic controller, ladder logic, okay, and ask it to analyze this image and give an overview of the control system. So this looks like a saw, fan, and oil pump, a safety system. It's looking at fan, be able to control this equipment with emergency stops. And it does a fairly good job going through this ladder logic as well and explaining what each of the blocks and lines do on this ladder logic. Okay, so let's get to communication now. So email and reports. So a lot of time is spent email. This is just a hypothetical student here with a request about a request to write a letter of recommendation. And so I get many of these from students, and I spend quite a bit of time thinking carefully about what to put in the letter, but I just wanted to see what it can do to help me with speed up some of that process and also increase the quality of what I put in there. So here's generate a reply. I received this email from Ryan. Write an email response to him with an indication of support to write this letter and any other letters of recommendation that he needs. So here's a response. Does a fairly good job, maybe a little bit too verbose. Maybe I should put there, I'm a professor with very little time. Write a clear and short email response. So maybe that would make it more believable that it came from me. Okay, so now write a draft letter of recommendation for Ryan. Include additional information that he's an excellent TA and that we've known each other for 3 years. He's been 2 of my courses, worked as a TA for me as a research assistant. Add information that he's written a publication and is currently submitted to a journal for review. He's a second author, but still had a substantial role in the paper, writing the concepts, developing the code, etc. Okay, so here is a summary letter of recommendation that I can use and then start to modify if it doesn't quite capture what I was trying to say in that letter of recommendation. Okay, so one other development that's happened recently is that the ChatGPT-4 has been updated. So now for certain users, you can upload many types of documents, working with PDFs, data files, Excel files, or any other document you want to analyze. Just upload and start asking questions. Now also it includes access to browsing, advanced data analysis, and DALL-E is now automatic for some of the image generation as well. So a nice upgrade to GPT-4, and I assume we're going to see more of these types of upgrades. We already have the opportunity to interact with it through voice, through the app. So there's other ways to interact with this tool that's going to make it easier to use for the types of data that we want to give it and help us analyze. So let's create a dynamic simulation program in Python Gecko for this 2-tank system. So I wanted to see if it could just use an image and develop a dynamic model for this system. And you can see here it does a very good job. Now some of the parameters aren't quite correct. I didn't give those in the problem description, but it could develop a dynamic simulation of this 2-tank system. Too fast of a dynamic there. Okay, drained each one fairly fast. So the inlet or the outlets to each one are too big to make this problem really interesting. But overall, it did a very good job of generating this Python code to simulate this system. Now let's do something just a little bit harder than just a 2-tank system. Here's a reactor. I'm going to develop a dynamic simulation of this continuously stirred tank reactor, assume liquid full, and first order kinetics. So it defines the symbols, it creates a mass balance and an energy balance here with some example parameters, and then develops the equations. Now in each of these applications, I took this code and then ran it. There were only 1 or 2 things I needed to change from it, but overall it did a very good job of creating at least a template for me that I could go in and edit with some minor edits to create a realistic simulation of this reactor. All right, so many things that you can do. A lot of this is really how do you use these prompts? How do you create effective prompts to be able to get what you need and also analyze the result so that, if it's hallucinating, if it's doing something that we don't expect, that you can recognize that as poor output. So you're in the driver's seat, you have this effective tool that you're using, and how do you make sure it doesn't steer off the road and it keeps between the lanes, the constraints that you've set. And so a lot of this is the prompts that you give it, and you can even follow up. If it didn't get it quite right, you can ask it to do something differently or modify a certain aspect of this. And so this is where the prompts really come in, and there are many really good cheat sheets that are online that kind of help train you, give you ideas about the prompts that you can use for these to create it to be more effective with this. Okay, so let's look at this data from an automobile. What are the insights that can be derived from this data? I pasted some of the data in. In the future, you can just upload an Excel or CSV file, and it was able to pick out some of the column headings of the data and then analyze the data as well to suggest some things that you could do for the analysis. And so I could follow up with this and create plots. I could create other things that I generate from this to be able to create a map or of the vehicle location and where it drove. Okay, so let's talk about, we've shown some examples. This really isn't going to replace humans. It's going to make us more effective. And as Salman Khan, I really appreciate one of his TED Talks that he gave recently. And he showed how AI is not going to destroy education. It's going to enhance education if we do it in the right way. And this is really about getting to this point where we get one-on-one tutors for each of us. So it doesn't just tell us the answer, but it helps lead us to the answer and helps us be able to learn more effectively. So let's talk about how you can use generative AI to help your training, to help you understand at a deeper level and get to some of these higher levels of analyses faster. So in a minute, I'll ask you to generate a Python exercise for me to learn additional programming skills. First, ask me a series of 3 Python questions in multiple choice format to assess my understanding of the language. Wait for a response before asking the next question. Sure, here's the first question. Okay, so what is the output of the following Python code? And so I respond here. Takes me, okay, C is my response. Thank you for your response. Here's the next multiple choice question. What is the following is the correct way to open a file? And then here's the final one. What is the result of the following code? And so I answer each of these. Fortunately, I got all 3 correct. And then it gave me an exercise, presumably a little bit harder on this exercise because I answered all 3 of those questions correctly for Python. But if I had missed one of them, it would have maybe adjusted the difficulty of the exercise based on my responses. So this is an example of where we can use a tool like this to be able to give us this one-on-one tutor, these one-on-one examples, and kind of tailor it to our understanding or experience. So the other thing I want to mention is really the business value that we bring in process systems engineering is got to get above some of these standard reports or ad hoc reports, query drill downs, alerts, alarms, things like that, and get to these higher levels of synthesis. And a lot of this is going to come through statistical analysis. It's going to come through forecasting, predictive modeling, and then optimization. What is the best that can happen? So not just what is going to happen if these trends continue, but what can we change to be able to optimize this system? All right, and a lot of this too, I'd suggest, is getting our work from just trying to remember Python syntax or CL code from a TDC 3000, or I forgot how this ladder logic works. So remembering that, and these tools can help us augment our abilities, okay? And also understanding, explain this code to me, include comments in this code, especially if you've inherited it from somebody else. All right, and then it gets us to these higher levels of creating new applications, new value, evaluating, critically examine the information and make judgments, or analyzing, taking the information apart and exploring relationships. All right, so we want to try to get to these higher levels of business value, and that's going to require more synthesis. And so generative AI can help with some of that synthesis. Now the problem is if it gives us bad results, it might lead us to the incorrect conclusion. And so a lot of that is this level as well, is really evaluating or analyzing the results of that generative AI. And that's where we're going to be strengthening more of our abilities as we start using some of these tools more effectively. All right, so I just wanted to share an experience. This was when I went to an offshore platform a few years ago during the height of COVID. And, one of our fusion splicers that I worked with, we were quarantining in a hotel for a week before we took the helicopter ride out to the offshore platform. And, unfortunately came down with a positive test for COVID. So I was out there by myself to do this project, and I had to learn how to do fusion splicing. Quickly got onto YouTube with another engineer, and we learned how to do fusion splicing of the fiber optic cables, and ultimately made this project a success. Now, one of the things that I also had, working down in the bottom of this pontoon in the depths of the ocean, is that I didn't have internet connection there as I was doing this project and trying to modify the code that I had created for our specific installation. What we wanted to do is be able to calculate the load on the tendon tensions and be able to replace some of the load cells that were there with this fiber optic solution. And it involved a lot of programming, a lot of data processing, and I didn't have access to Google. I didn't have access to ChatGPT. It wasn't out yet. And I just had to kind of program this from memory. And if I needed to do a Google search, I had to hike up equivalent of 12 stories, and many flights of stairs to do a Google search, and then go back down to this data server rack and finish the programming. So it taught me the value of really understanding this at a deep level and be able to do these projects without the aid of some of these assistive tools. And so for that reason, I put together a series of this additional course. It really inspired me because most of the problem was not in the detailed theory or mathematics. It was really the data-driven engineering, how we use data and use it effectively to help us make decisions or to produce results. So just transferring data from one computer to another, being able to process that data and put it in a database and be able to extract it, and just some of these mundane things that we don't even really think about, but are really the foundation for a lot of the applications, getting cleansed data and helping use that data to help us analyze something and be able to make a decision. Okay, but there are other courses as well that go along with this. I just want to highlight some of those as well and how we can potentially use generative AI in helping us learn or understand some of this content as well. So there's data-driven engineering. You also have engineering optimization, dynamic optimization, which includes advanced process control. Okay, this is an introductory process control course, machine learning, and engineering programming as well. So all of these courses are available for free online for self-study. I'll just highlight one example from the engineering optimization course. And this one is, many different examples here: introduction, modeling, constrained, discrete, genetic algorithms, constrained, robust, optimization, dynamic optimization. But here's one that's just a tubular column example. Okay, and you can scan the QR code if you like to bring this one up. But let's just see what generative AI can do for us. So we want to optimize. We're going to optimize a tubular column design with Python, and we'll use the Gecko package that I developed with Logan Beal. Okay, so optimize a tubular column design, and here's an example. It does a fairly good job of creating the variables and the equations as well. And this might be for like a drill string, or it might be for a building, or it might be many other reasons why you might use a pipe to be able to support some type of structure. Okay, so here we go. It's going to go through and explain the program for us as well, solve the optimization program, and explains each line of this code. Now this is the 3.5 turbo model. All right, now we also want to create a contour plot of the optimal solution. Now this is what it came up with. We have the wall thickness versus diameter, and then here's the optimal column weight. But we also have some constraints in here as well. So I'll also show the constraints on the contour plot. And okay, so we want to add contour lines, and what we want to eventually get to, I'm going to show you the solution that I came up with for this problem. It'll show us the optimal solution. It'll show us the contour plots for the stress constraint and the buckling constraint, and then the cost for the objective as well. And so you can see the where it satisfies both of those constraints. For the buckling constraint and the stress constraint, it has to be to the right of both of those and with the lowest cost. So in this case, its feasible region is right here, and the lowest cost is going to be right there. So it can help us explain the solution, not only generate an optimization solution, but help explain the optimization to us as well. This is not explainable AI, this is explainable optimization here. But explainable AI, why you gave me that answer is also a very important field of research and development that's needed for generative AI. All right, so a little bit about research group. I have many fantastic graduate students. Just want to give credit to them for the excellent work that they do. Also, please connect with me as well on LinkedIn. Love to hear about your research or your projects that you're doing with generative AI. So just a little bit about our research. We use this temperature control lab for many of our case studies to validate the methods that we're developing. So for example, using Transformers for model predictive control, using transfer learning, some of these other methods that we're exploring right now for process systems engineering, not just natural language processing. And so we use this benchmark temperature control lab to really help us apply this to a real system. So that's one of the developments that we've made. Also, here's an application in microgrids. Work a lot on microgrids. This is an example of a high altitude, long endurance aircraft. And I'll just bring this up. Worked on this with Meta or Facebook for a couple of years. Covered with solar panels. This was before really the the Starlink or the satellites for communication. They're thinking balloons or some of these 60,000 foot airplanes, drones that could fly around and help deliver internet. But I think, the low Earth orbit satellites have really replaced these. But we did some work with them on the feasibility and simulation optimization for this microgrid system. Also, data availability, worked quite a bit with companies and others that really want to take advantage of this new data. So this data is there, and you're drowning in data but starving for information. How do we extract value from this? And this is an example in drilling where this is the IntelliServe drill pipe. All right, and two-way high-speed communication in the drill string, and what can you do with this data? So we explored some of those options in terms of detecting kicks and be able to automate the kick response, also to help the drilling efficiency as well. Also, there are many types of simulators out there, and these are high-fidelity simulators, and there's also quite a bit of data as well. So we're very interested in the intersection of these high-fidelity models and the data, and what can we do with hybrid machine learning to be able to utilize the strengths of both of these approaches in a unified approach. So you don't have to choose one or the other. Either I'm going to create a detailed simulation using physics-based knowledge or the data, but how do I combine these into a single platform? And so we've been working with Seek on this. They have a very nice platform to be able to help analyze industrial data. And we're also working with Pacific Northwest National Labs on vitrification of nuclear waste and using machine learning in the optimization code to be able to help to optimize the waste loading within the glass. Also working on a Department of Energy project. This is introducing small modular reactors, these nuclear reactors, especially with molten salts into the grid, and how do they work together with solar, combined heat and power, hydrogen storage, and others to be able to deliver these combined solutions that utilize the strengths of both of the technologies. Much like we're using the data-driven approach and the physics-based model and combining those into a unified approach to be able to solve some of these problems. Well, appreciate your attention, and I'd love to hear some of your comments about how you're using generative AI in your process systems engineering work as well.